Hello everyone. Here I bring you the questions of research and development in the chemistry field. So those who have completed their BSc or MSc in the chemistry field, this will help you. So let us see the questions one by one. I don't know. Okay, right. So let us see the difference between aliquot and diluent. What aliquot is? It is measured subvolumes of the original samples, and the diluents. These are the material which sample is diluted. For example, if you are from the chemistry background, you must have done the experiments in the laboratory, and we have the beakers labeled with the dilute solutions and also with the concentrated solutions. So I'm sure you know what is diluted. We dilute it with mostly with the water base. So let us see the next question. What is molality? So molality is the number of solutes that are present in 1 kg of a solvent. Okay, so what is exactly solute and solvent? So you are aware about solution. Solution is formed by the mixture of solutes and solvent. Solutes are in the lesser quantity and solvent are the one which actually dissolve the solute. For example, if I talk about the mixture of a salt solution, right? So in the salt solution, salt is an example of a solute, and water, where we take it as a medium to dissolve the salt, is known as a solvent. Let us see the next question. Titration. Again, if you are from a chemistry background and if you have done your experiments in the laboratory, I am sure this is the basic of the titration. It is the process to determine the molarity of a base or an acid. So in this process, the reaction is carried out between the known volume of a solution with a known concentration against the known volume of a solution with an unknown concentration. And you must be aware of this formula, that is NaVa is equal to NbVb, where any of this variable is unknown to us and we can find through this formula. And if I have to show you something about the titration, you can see that how we do the titration. We use the burette, and we have this beaker. So in the burette we fill acid or base, strong acid, strong base, or weak acid or weak base, and we do the titration with the strong acid, strong base, or weak acid, weak base. So here we can see the diagram of burette, which is filled with the standard anode solution, and we are titrating it against 20 ml of acid solution. So how do we exactly know that when your titration is completed? So we call it the end point of we call it the end point when we just see the faint pink color appears, or it can be any color. That color, to bring that color, we need to add what we call is the indicator, and there are too many types of indicators available in the market, and the one which we use in the laboratory are the methyl orange and the phenolphthalein. And phenolphthalein is actually, it brings out the faint pink color, as you can see on the screen, right? So that's it. Let us see to the next question. What is buffer solution? So a buffer solution is a solution which has a stable pH. If you even add acid or base in that, it will not change the pH of a buffer solution. And that means it is a blend of a weak acid and its conjugate base, or vice versa. So on adding a small amount of base or acid to buffer, its pH hardly changes. That what exactly a buffer solution means. Now if I have to give the example of a buffer solution, I will say acetic acid and sodium acetate, right? So you may be asked that how this buffer solution works. So in buffer, when hydrogen ion is added, that is H plus ion is added, it will be neutralized by the base in the buffer. So you know that H plus ions are they get neutralized by adding OH minus ions, right? So it balances the pH and it hardly changes the pH of that solution. On the overall pH of the buffer solution, this neutralization reaction will not show much effect. While when you select an acid as a buffer solution, try to use an acid that has a pH close to your desired pH, and this will help your buffer to achieve a nearly equivalent amount of acid and conjugate base, so that it will enable to neutralize as much as H plus and OH minus ions. Now you may be asked what exactly is a mole. So while we were doing the physical chemistry or an analytical chemistry, we we are used to this term during lots of calculation which we come across in chemistry. So mole is nothing but it is the unit which we used to define the number of chemical substance present in a substance. Uh, it is the amount of a substance which consists of the same number of chemical units as there are atoms in exactly 12 gram of pure carbon. So if you are asked to calculate how many moles of glucose are present in 320 ml of 5.0 molar of glucose solution, so stepwise we can calculate this. First we can convert the given ml solution in the liters. Second, we can use the formula m into v, that is molarity into volume. We can directly calculate the moles. So 0.320 multiplied by 5, we get the answer 1.6 moles. Okay, so that is the number of moles of glucose which is present in 320 ml solution. If you are asked the difference between fractionation and distillation, so this is a well-known image of a fractionation distillation, that we fractionate the mixture of petroleum, and all the mixture of the petroleum are having near about close boiling point, I can say. So as you can see in the tower, we are having a petrol which boils at 150 degrees Celsius. We are having kerosene which boils at 200 degrees Celsius. So among this mixture, we will first separate out petrol mixture. Before that, we are having gaseous petroleum, right, which has a very low boiling point, as low as 20 degrees Celsius, which we can remove away. Then we can separate the gasoline, that is petrol mixture. Then we can separate out kerosene and so on. And at the last, we are having this lubricating oils, which has a very high temperature, around 400 degrees Celsius. Now in the distillation method, this is the diagram of the distillation method, where we use a condenser, especially a condenser. What is a condenser? A condenser is the instrument which we use to control the temperature, to maintain the temperature of the vapors inside it. For example, we are having the water inlets and water outlets, which continuously flows throughout that condenser, and it will help the vapors to settle it down into the liquid form, and then after we can separate it into the beaker or flask. So here we heat the substance in the flask, which will convert into the vapors. There can be two types of the substance which can directly convert into the vapors. We call them sublimation process, and there can be the process where we heat the liquid, it will transform into the vapors, right? So we can use solid as well as liquid in the flask, which will heat the substance, convert into the vapors. The vapors will move towards the condenser. The water inlet and outlet process will settle down the vapors around the tube of condenser, which will be taken out. The vapors which then converted into liquid then will be taken out into the beaker. Now, so both methods are used to separate the components present in the solution, which is based on the melting points. Here, distillation is the technique which is used when the boiling point of chemicals are different in the mixture. And then we are having fractionation, and this technique is used when the boiling point of the chemicals are close to each other, as I told you, which we have already seen the example in the petroleum mixture where the temperature was quite close to each other. Now, uh, what formula we can use to calculate the pH? So this is the formula, that pH is equal to the minus log of H plus ions, or pH is equal to the minus log of H3O plus ions. So what is the main difference between molality and normality? So both techniques are used to the amount of the chemical present in the solution. However, they are almost similar but differs in molarity. Differs in the given way that molarity is used to know the total amount of molecules in a 1 liter solution, right? And it is expressed in moles of a compound per liter of solution, while normality is used to know the total number of reactive units in 1 liter of solution. It is expressed as moles of a compound per liter of solution, and it is expressed in equivalent per liter. Valency. Now, if you had done the chemistry, which is related to the electrons, protons, neutrons, where we use the VB, valence band theory, and molecular band theory. Okay, so there we use this term valency a lot, and if you are familiar from there, valence is nothing but a property of groups or atoms equal to the number of atoms of hydrogen that the group or atom could combine with or displace it in forming compounds. Avogadro's laws. If you are a student or a person from chemistry background, you need to know Avogadro's law. So according to this law, at the same temperature and pressure, at the equal volume of gases contain the same number of molecules regardless of the chemical nature and physical properties, where we have this Avogadro number, which is equal to 6.023 into 10 to the power minus 23. Now, if you are asked to define the molecule, which is from in the organic sense, we say that a molecule, that means when a hydrogen atom is less than the ratio of the carbon atom, then such molecules are referred to as an organic molecule, where we have more number of carbons and combination of a carbon and hydrogen, where you can understand me how we relate a molecule, right? Which metal is used to extract copper from the solution of copper sulfate? So we are using this ferrous, that means iron metal, to extract the copper from the copper sulfate. Explain what is the chemical composition of a fat in the human body. Do we ever try to figure it out that what is this fat made up of in our body? So here it is. Fat is made up of glycerides plus phospholipids, glycolipids, inositides, and tocopherol. Sorry for me to pronounce this name because I also came across these names first time. I just studied glycerides and maybe the second one, but I am not aware about the last three ones. I did not study, so apologize for that pronunciation. You can Google it and you can know it in a more better way what it is pronounced as. Next question is monomer of a polythene. So the monomer of polythene is made up from ethylene, right? Now, what is the formula you will use to calculate how many milliliters of 5.5 molar NaOH are required to prepare 400 ml of 1.5 molar NaOH? This is very simple. One of the volume is not given to you. Another volume and molarity is